Hi dear students, have a look at the drawing room of your house. You will see appliances like television, fan, tube light, etc. Now if you look at your kitchen, you will find appliances like refrigerator, microwave oven, mixer, etc. If you peep into your study room, you may see instruments like computer, air conditioning, machines and all. In all these appliances, the common thing is that they all are operated by a single source of energy which is called electrical energy. Now imagine that electricity fails in our house. Our situation will be very difficult, right? We won't like that electricity goes out, especially in rainy seasons. When electricity is not there, we feel very uncomfortable. The electricity empowers the places like school, offices, industries, hospitals. So that tells you that it is not only usable or helpful in our homes, but at all the places. See, electricity is an indispensable part of life in our today's world. It is a controllable and convenient form of energy for a variety of uses in houses, schools, industries, or everywhere. The modern industrial societies, the modern world, in fact, it relies heavily on the use of electricity and focus that not only for lightning but for running factories, running the machines, heavy machines, small machines, running the information and communication systems, heating, traveling, cooking, entertainment. Electricity has made our life faster and easier. You all might be wondering why I kept this picture as the introductory picture. Now, this picture you can see a person or a superhero having electricity as his superpower. Yes, he is Thor and he is the god of thunder. Now, because we are studying a chapter related to this phenomena of science, that is why it will be very interesting, right? Because lightning has a relation with electricity. So let us continue with class 10 science physics in that chapter number 12, that is electricity. So far as we have completed chapter 10 and 11, in that we have studied optics, but now 12 and 13 chapter we will be dealing with electricity and its related phenomena, right? So now let us start with the main topics of the chapter. So in this chapter we will study electric current and circuit. In that also we will study very basic processes. Then we will have electric potential and potential difference. Then circuit diagrams, what is circuit, symbols also we will see. Then comes the very important Ohm's law. Then factors on which the resistance of a conductor depends, resistance of a system of resistors. Again in this topic we will have derivation, which is very important, heating effect of electric current, electric power. So these were the topics. Let us start with the most basic thing which we will be studying in electricity. Now electricity we are studying in two types: static electricity and current electricity. Now static electricity is also called electrostatics, which is a branch of science in which electric charges at rest and associated phenomena are studied. You might have done that small activity of small pieces of papers which can be attracted by a plastic comb after combing through dry hair, right? Similarly, when a glass rod is rubbed with silk and a plastic rod is rubbed with fur, you can see there is some attraction and repulsion phenomena. So that is nothing but a kind of electrostatics activity, right? But in this chapter we won't deal with this because this will be dealt by you in further standards. So in this chapter we will detail study about current electricity, which is a branch of science in which charges in motion and associated phenomena are studied. Now, whatever current is flowing in the wires and conductors in all the types of circuits are under current electricity, right? So, first of all, what is electric current? Electric word is related to the chapter electricity, but what exactly is current? Now, in current in literary meaning means flow. Like we use water current word as flow of water. Similarly, there is air current, that is flow of air. Same way, there is the concept of electric current, that is nothing but flow of charges. Now the next question arises, what are charges? So let us study in detail about electric charges. Now electric charge is the property associated with the matter due to which it may produce electric and magnetic effects. Right? Now these charges are nothing but the subatomic particles. You all know about the atoms and subatomic particles. So that is why these charges are categorized into positive and negative. The positive charges are protons and negative charges are electrons. Positive charges are due to the protons and negative charges are due to electrons. Now the unit for charge is coulomb, that is represented by capital C. Remember that electric charge is a physical property or physical phenomena, right? So it will have some formula as well as some unit. So we are denoting the unit of charge as coulomb. Now then comes the magnitude. The magnitude of charges for electron is minus 1.6 into 10 raised to minus 19 coulomb, and charge on proton is plus 1.6 into 10 raised to minus 19 coulomb. So 1.6 into 10 raised to minus 19 is common. Just because electron are negatively charged, we will have to put minus in front of 1.6. Proton being positive, we are putting plus 1.6. Like charges they repel and unlike charges they attract each other. That means the positive and positive will repel. Same way negative charges will repel, means go away from each other, and positive negative or negative positive they will come close to each other. That means they attract each other. Metallic elements like iron, copper, these substances have some electrons which are called free electrons in their structure, and they flow to constitute the electric current. So that means the current which is said to be flowing, the current which is formed, which is cyclic in the circuit, they are nothing but the free electrons that are flowing. Okay, so whenever we talk about current flowing, that means they are nothing but the free electrons which are flowing. Now substances are categorized into two types, conductor and insulator, based on their ability to make the electrons flow. So substances which allow the electricity to flow through them are called conductors, and substances that does not allow the electricity to flow through them are called insulator. All the metals or metallic substances are conductors or good conductors. Rubber, glass, plastic are insulators. Okay. Now, if you want to find out any physical quantity related to electric charge, we have a special formula Q equals to Ne, where Q is the quantity of electric charge, N is the number of electron, and E is the charge on each electron. Right? So if you know the number of electrons, you can easily find out the total quantity of electric charge by using this formula. Right? So moving on, we will discuss about electric current. This means the rate of flow of an electric charge through a conductor in some time. Right? Rate of flow, that means how much electric charge is flowing through a conductor per unit time. So we make the formula electric current equals to quantity of electric charge upon time. Now electric current is represented by the symbol capital I, and thus we make the formula I equals to Q upon T. So I is for current, Q is for quantity of electric charge, T is for time. SI unit, the standard unit of electric current, is coulomb per second. As you see in the numerator, we have quantity of electric charge in coulomb and time is measured in seconds. So coulomb per second. But in the memory of the great scientist Andre Ampere, we dedicate a special name of this unit as ampere. Okay. So electric current can be measured in ampere, and ampere equals to coulomb per second. Now most ampere thing and most ampere definition for 1 marks will be definition of 1 ampere. So if you want to define 1 ampere, just put 1 in front of every unit, like 1 ampere, 1 coulomb charge and 1 second time. Okay. So let us now make the formula. 1 ampere is the current which is flowing when 1 coulomb charge passes through the conductor in 1 second. So this is the self-made definition of 1 ampere current. It is a current flowing when 1 coulomb charge passes through conductor in 1 second. Now, there are different units of electric current. They are milliampere and microampere, right? They are the smaller units because whenever we deal with current in our laboratories in schools, we deal with a very less amount of current, right? So milliampere you can see M and capital A, and microampere we have mu A. Okay, 1 milliampere is 10 raised to minus 3 ampere and 1 microampere is 10 raised to minus 6 ampere. Now electric current flowing through any conductor, any wire, can be measured by an instrument called ammeter. Ammeter is just looks like this. We all have this ammeter in our school laboratories. So whenever you find a free time, please go and check the ammeters. Now, based on the formula of current I equals to Q by T, let us solve a numerical. These type of numerical can be asked in short questions. A current of 0.5 ampere is flowing in a conductor for 10 minutes. Find the amount of electric charge flowing in the circuit with this time, while this time. So two things are given. Focus on the values. Current 0.5 ampere, time 10 minutes. So what we have done is to write current in ampere only, but time in minutes is converted into seconds. So 10 minutes is 10 into 60, 600 seconds. So as we see the formula I equals to Q by T, we cross multiply and find out the formula of Q. So that will be I into T. So just multiply 0.5 into 600, that will give you 300. Remember that we are finding the amount of charge, so unit will be coulomb. So this is how you will apply the formula to find out the. Now moving forward to our next topic, that is very easy. You all can see in this small video that there is a cell, there is an electrical appliances which are connected with wires, and there is some kind of flow. Okay. Now what is electric circuit? It is a closed and continuous path through which electric current is flowing, right? So that path is called electric circuit. Now what are the main things that are there in electric circuit? So electric circuit has various components including a source of current, any load or appliance, key or switch, and all these are connected by metallic conducting wires. Okay. Now for safety purpose we can even have a fuse in the circuit, and the connecting wires are generally made up of copper, and direction of current in the circuit is taken from positive to negative terminal. So these are few basic information related to electric circuit. You might have studied this in lower standards as well. Well, we are not going to in detail about electric circuit and its component. So let us see the next part, that is the symbols that we are using in electric circuit, because we will be dealing with many diagrams. So we cannot draw all the component as it is. For example, if it is a light bulb, it is too tough or monotonous or time wasting to draw a real electric bulb. So what do? We have converted the whole bulb into a symbol, right? Same way there are symbols of electric cell, battery or a combination of cell, plug key, that means switch, open switch, close switch, wire joint, wire crossing. So these all things, this ammeter, voltmeter, these all things are drawn as symbol so that they are very easy to draw and they are very easy to understand. Clear? So that is why we use symbols in electric circuit. Now that's it for this video, but I have something for you. So you have 3 comment questions. Very carefully you see, mention any 5 electric appliances which according to you are most important in your daily life. So that This answer will be a bit personal. Every one of you will have to think of 5 electric appliances which are most important to you. The second question is who first invented cell? So you have to find out from the internet that who was the first person who developed the concept of electric cell or first invented the cell. And the third one is a kind of calculation based question. See carefully, a charge of 5 coulomb flows through a circuit for a minute. So charge is given and time is given. You just have to find out the electric current. So that's it for this video. We will meet again with the next video and the next concepts related to electricity. That's it for today. Thank you.